So just the context in Ireland, okay, so we have about 1.66 million hectares. Similar to Germany, about 85% is degraded. But from what I've seen this morning, is not degraded to the same extent as here. Our issue mainly is pasture, and in particular deep drain pasture for dairy and for beef, whereas you guys have a lot more tillage and it's very patchy, whereas we do have bigger contiguous blocks. But that's essentially the state of play in terms of us. GRI as an organization, we set up specifically to look at the 77% of the peatland that is owned by farmers, because there's funding to restore the other stuff, but not really for farmers. So it was our belief that they needed help to do this. And that's what we did. So in terms of so that's the setup. Just one of the things we encountered when we were doing the project was there's a huge lack of awareness. Nobody has any clue how much carbon is stored in peatlands. Also, people think trees everywhere are a good idea. That's another problem with peatlands. So just some of the issues. So again, just to press that home. So we have 21% of Ireland is covered in peatlands, and it stores 6 to 7 times more carbon than in all of our forests. So about 70% of our soil carbon. There's very high emission levels. And in terms of the quantity, so as I said, when I'm explaining to the farmers, this is always an issue. So in a very small amount of peat, you have as much carbon as in a mature spruce wood. We have, you have nice forests here. We have these tree farms of spruce all over the place, which is going to be a problem when the beetle comes. So just very large amounts of carbon stored. If you have 2 meters or more, it could be up to 1,000 tons of carbon per hectare. And 4 meters or more, and we have quite a lot of raised bogs. It can go up to 15 meters deep. You're talking huge quantities in carbon. So people talk about rainforests. They're not particularly productive. So I always like to give you, if you're familiar with a giant redwood forest in California, then you're talking about double, as much or more in some of our peatlands. So again, it's just to press that point home to our people. And then here's just another visual representation. So this is another really bad idea that we do in Ireland and the UK. We plant forest on peat, so this is blanket bog. But again, just to make the point, there's more carbon in this little bit of unplanted blanket bog than in all of the forests on the mountainside. So huge quantities of carbon, very little lack of awareness in relation to this. And then just here's another couple of images. Here's my colleague, Dr. Heaton, with just depthing. So we were looking at, in our project, we were looking at farmers with peat grasslands. And what we found, they all had peat grasslands, because they also had what we call cutover, which is basically where the peat was drained and it was cut for fuel to heat the house. That's how, because all of the forests were chopped down in Ireland, that's how everyone kept their families warm. And then they also have a bit of raised bog, maybe degraded or damaged. So this is a very shallow bit of raised bog, which is 4 meters deep. So 2,000 tons or more of carbon per hectare. Again, another issue with the farmers, they thought the rocks were coming up through the fields. They had no idea the peat is going, and it's going for good. It's not coming back again. So again, this is another image we always use. This is, if you're a bit of a peatland or an ecology nerd, the Holm fen post in Cambridgeshire. In this case, the landlord sank a post to the bottom of the bog, and it was drained. His idea was that the bog was like a big sponge, which it is kind of, but he wasn't aware that it degrades and disappears into the air and water. And this is today, you can see, without any cutting or harvesting of the peat, this is how much peat has been lost. And again, this is another issue for some of our farmers where they have very shallow fields. They only have a few years productivity left in these fields. So this is a big issue. And it's essentially been lost. Depending on how deep the drainage is, it's being lost at a rate of 1 to 2 centimeters a year. And of course, that equates to very high levels of CO2 emissions. So we have a range, we have a real mosaic of peatland habitats. And depending, if you look at the slide previously, if I get it right, yes. So this is slightly degraded. It might be emitting 1-2 tons of carbon a year. This is planted peat forestry. That could be emitting, 10 tons maybe. And then if we come to grassland, this is deep drain peat that could be emitting up to 30 tons of CO2 per hectare per year. So this is the issue that we had to deal with in our project. Just some of the other issues. So again, that's the greenhouse gas side of things. The other issues, of course, is when the peat degrades, it doesn't all go into the air. Some of it also goes into the water as dissolved carbon. and if it's bare peat, it will be eroded as particulate matter. And so you have this rate of emissions into the water, so it's an important source of water pollution. This is just what I mentioned. So this is one of our polluter farmers, and just down from here, there was a very shallow drain, and about 30 years ago, with a group of farmers, they made the shallow drain a very deep drain, about 4 meters deep. And he's gone from this much soil to, oops, sorry. Where are we going? Going the wrong way again. Yeah, there's about 10 centimeters left. So this is a big issue, because of course, when you get down to the lac or the marl or the blue clay underneath, drainage is a huge issue. You know, you're probably going to be obliged to do polluted culture, even if you don't want to. So that's the issue there. Flood control, of course. So both flood control and supply of water in the time of drought. So this is another issue. We're also kind of subjected to the vagaries of climate extremes. So in terms of storage, we have big flooding, same as everywhere, we have flooding issues. We have not enough water when it's dry. So this is one of the things that we highlight. And then also, of course, there's the biodiversity angle as well. So Ireland is home to 50% of everything that's left in terms of Western Europe's raised bogs. So it's a key country for that, as well as 10% of the world's blanket bogs. Fen, I think this is, you have a lot more of that here. We're more raised bog country, but fens, we have a few, but not so many. And in terms of the threatened wildlife, so we have the marsh fritillary, Euphodria serinia. We have curlew, which is down. All of these are crashed in numbers. So the curlew, the lapwing, the skylark, the meadow pipit, the merlin, which of course is the little bird of prey that catches birds on the bog, very rare, shorted out. And we also have, we don't have many species in Ireland. We only have subspecies because we've only been separated from England for a short while, but we have our own Irish grouse, red grouse. So this is that. And then of course, what will happen if we don't raise the water table with this dry peat? Well, we've seen the rate at which it emits just without any burning, but of course, as temperature, you know, we will have fires. And this is a big fire, I think it's in the Peak District in England. And of course, once that happens, it takes hold of the peat and it burns. So the emission levels go off the scale. And of course, if the peat is too damaged, it can never be restored. So this is kind of the scenario that will play out if we don't do this. If we don't get these re-wetted. So GRI's work, I said we're entirely farmer focused because we don't think they're a very neglected group of stakeholders. We need to provide, because it was my idea that people want to do things, but if they don't get advice or options or support or choices, you know, they can't and they won't. So this is kind of what we set out to do. And with that in mind, we did help some farmers in Mayo re-wet some bogs, and then we put in and we got the farm carbon EIP. Sorry, I'm talking okay. I'm not going too fast or with a mad accent or everything. It's okay. Good. Perfect. Okay. So as I said, when we surveyed the farms, the project was just peat grasslands, but I don't believe in just looking at small things. We looked at the whole farm. So there was the mineral part of the farm, and we did measures. And then there was the peatland part. And as I said, that included grassland, cut over, maybe plantation forestry, and also bog and or fen. And we had about 20, and when we did the peat depth thing, you know, there was nearly 300,000 tons of carbon stored in 180 hectares, and we did re-wetting, and we reckon we avoided, you know, up to 200 tons a year. Just again, to give you an idea, here's the figure, yeah, here's that image again. Just in terms of so obviously, if you think about it, our peatlands, they were drained, you know, a peatland is 95% water, so you need to drain it to be able to cut it, to use it for fuel, and then you can reclaim it for agriculture. So people started at the edges. So those outer edges are now grassland or forestry. Then there's a middle zone, which was never reclaimed, which is cut over, so it's very diverse. And then there's the remnant bog in the middle. So if you look at the remnant bog in the middle, and this isn't actually in the middle, but you can see there's huge quantities of carbon stored. And then if we go out, but even for the grasslands that were the core of the project, there's still up to 1,000 tons of carbon per hectare stored. And there's those very high levels of emissions of up to 30 tons CO2 per hectare per year. So this is what we had to address. And the way we did that was we always gave it was a voluntary program. We gave the farmers options and we compensated them for any of the work that was done. So we paid for all of the measures. And One of my colleagues, Bastian, Dutch, always great to have a Dutch person on board when you're doing peatlands. Bastian Mollerman, he developed a method for predicting emissions from peat grasslands. And essentially he took, because the trouble in Ireland is we're very deficient in country-specific data. So he took from other oceanic climates, from the UK, from Holland, and the bit of Irish data. And essentially what that told us was that every 10 centimeters change in water level is equivalent to 5 tons of CO2 per hectare per year. So all of our farmers have very deep drain fields. So even this much is beneficial because it's re-wetted peat, which is going to stop degrading. So we had a range of measures. So we had minimal re-wetting, partial re-wetting, and full re-wetting. Where the farmer was only doing extensive summer grazing, we were able to do a full re-wet because that doesn't impact. It dries off in the summer, the cattle can graze and so on. Another thing that we identified which was key was that 40 centimeters below the surface. So, you know, given that all of our fields were drained at least to this depth, you can go to 40 centimeters below without changing anything on the field surface. It doesn't impact the productivity, doesn't change. So the farmer's business as usual, but obviously they're paid for the avoided emissions from the re-wetted peat. And this is just, essentially we had the two methods. We used peat dams or we used plastic piling dams. And what we always did with the plastic piling dams, because obviously peer pressure is an issue, I presume it is here as well with farmers. The neighbors are looking in on a wet field, a flooded field, and then they're going to be tutting. So we always gave them, we had adjustable levels. So if it had been a very high amount of rainfall, they could release, let it drain, and then block it up again. So this was very successful. But the question is, 40 centimeters below is still 15 to 20 tons of emissions per hectare per year. So hence polludiculture. And we set up Ireland's first 2 polludiculture farms. This is one of them. This, as I said, it gives you an idea. So this is one of our, I think you have similar sites in Germany. This is one of our big extraction sites, Bordnemona. This is 1,300 hectares of bog behind this that was cut for fuel. This is the area of cutover, and this is some plantation forestry. So this is where we did set up one of our first polludiculture farms. And again, you can just see the emission factors are very dodgy. They're working on them. But, you know, essentially, if it's in fairly good condition, there's lower emissions. But the grasslands are the king of the emissions if they're deeply drained. So this is what we were focusing on. Yeah, 2 issues, obviously, with the grasslands. You know, peat is undegraded carbon, so when it degrades, hence you have all the CO2 emissions and the emissions into the water, but also you have the nitrates associated with the grass are released and they feed the grass. So they're very good for grass productivity, dairy and beef farmers. So that's one issue. And then the other one, of course, is when the water table comes up above that 40 centimeter below mark, the peat gets too soft and the animals will sink into it and they poach the ground. So we did an experiment because Irish farmers want grass. Our first legends, which go back, they believe, to before BC, so at least 2,000 years old, are wars about cattle. So Irish farmers want grass. So that's what we wanted to give them. And so we did a successful experiment where we identified a mix of grasses, legumes which will fix nitrogen, herbs which will grow well, and that the water table can be high. So we're working on that and we're getting the results from this. The other thing, and you can see here, so obviously this isn't about, I was in Leitrim earlier this year, I should have taken pictures. You would not believe, if you saw the fields, you would be like, how can you do farming with this? Anyway, but that just gives you an idea. This is poaching is the issue, and the reduced productivity. So again, this is just some of the figures from Holland, I think. Summer grazing, obviously you're looking at 2 to 5 tons of dry matter a hectare per year, which is down from the average of 10 to 12 tons. So big loss in productivity. So this is what we were trying to address with our wet grass experiment. Okay, I'm going to flick on. That's just our objective. Yeah, so then 40 centimeters below, okay, business as usual. But then our farmers have been draining peatlands for generations. Their uncles, their fathers. You know, first of all, we have to persuade them to raise the water table, and then we're going to grow different crops, you know. So we had to be able to answer the question, what use is wet peat? So what we did was obviously there's Greifswald has a great list of polludiculture plants, but the Department of Environment in England has a kind of simplified version with about 100 of the most potentially viable, commercially viable crops. So we did the grass and then we did the other ones, which we thought would be most suitable. So that sphagnum, Typhoid, cattails, and the soft fruits were the ones that we worked on. Obviously, what we're talking about here is there's two possibilities. All of the environmental problems from peatland farming come from the fact that the peat is drained. And to resolve it, we need to raise the water. So what we see is the opportunity there is for carbon or nature credits. So you should have payments every year for having avoided emissions. But then on top of this, you can have the income from polluted culture. So this is what we're working on. And as I said, we set up the first 2 demonstration farms for this. These are just some of the figures. We haven't worked these out ourselves. You know, I'm always skeptical. You see figures of what crops are worth. But, you know, some of the polluted culture crops are a lot more valuable. And the benefit for our farmers is that, as I said, there's these 3 zones. So the outer zone is grassland. So they could potentially raise it to 40 centimeters below and get paid to do this with no impact. And they have cutover, which is wasteland, but is degraded and it's emitting. So it can actually be reclaimed with agriculture and be used to grow crops. So that's kind of our vision of things. This is just the artwork of one of our farms. So we don't just do peatlands, we do the whole farm. So we do a whole farm approach. So we do hedge creation, hedge laying, hares, corners and other things, but I won't talk about that because we don't have time. And this is where we're doing our bigger trials. This is our land scale farm. This is about 4 hectares here. So we have a big wet grass experiment. We're growing blueberries. Again, the literature suggests blueberries need to be drained to 50 centimeters below. But we're growing it, so far, we're growing them with a water table at the surface. Similarly, cranberries. And the benefit with these crops is once you've established them, you know, they're there for good. You know, cattails and other things, they don't need to be re-established. It's not, you don't need to drill them every year like you do with corn. This is our, so that was, sorry, I'm going the wrong way again, excuse me. Okay, so that was our land scale farm, but we actually started out with this one. So we call this our showroom, because it's a really handy, compact farm. Where, please, anyone come to Ireland, let us know. I'm happy to show you around. This is some of the best hospitality in Ireland. Everyone who comes here wants to come here again, because the farmer's wife, she does the best apple tart, the best soup, all with homegrown vegetables and fruit. It's amazing. So anyway, this is our showroom farm, and this is where we prove the principle. So we packed in as many different crops as we could. So we have herbs, we have vegetables, we have fruit, we have timber, we have horticultural materials, we have the building materials from cattails. You can also use the seeds for textiles. And we also have grains. So we proved the principle there, and then with the other farm, I got it right this time, we're doing it at the bigger scale. So the next step, we want to get to commercial scale. Okay, just to give you an idea, so this is, obviously this is emissions, just the kind of potential scenarios. If we continue business as usual, 30 tons of CO2 per hectare per year, the field's shrinking every year, it's disappearing, it's disappearing. Partial re-wetting, which we did a lot of, 40 below. You know, we have lower emissions, but we still have higher emissions. But then if we want to go back to a situation of carbon neutrality, then it's polluted culture. So we see this as a re-weigh. And this is just our vision of one of the sites. Hang on, I'll just go back. This one here. So this farm, this is the bog here. So that farm is here. And this is just how we see things. It's going to be a field by field. It's going to be mosaic patchwork approach. There's no one size fits all. All of this area has to be cattails, or all of it has to be blueberries or whatever. We do it according to the farmer's preferences and what the land is most suitable for. So what you can see here is this is the original bog, the coloured area. This was all reclaimed probably in the 19th century for fuel, and then it was reclaimed for agriculture. Then a big perimeter drain was put in. This is all cut over, and this is the remnant bog in the middle. So what we're trying to do is get funding to, because we think if we can get a successful example, there's about 30 farmers who own this area, where we can re-wet the whole area and do polluted culture, that will work, because they will get payments for the carbon, they will get new crop possibilities, and then farmers talk to farmers. They will go to the März, they will tell the other farmers, this is a good deal. So this is kind of how we see things. Okay, it's a bit of a vision of the future, but you know, you've got to have an idea where you're going to. So again, just to clarify, this is the remnant bog in the middle. There's about 80,000 tons of carbon in that. So that should be re-wet for biodiversity, for carbon storage, for water quality. The cutover area, which is being invaded by scrub like you have here, the birch and the willow, dries out the peat and causes issues. So this should be re-wetted. If it re-wetted, it could be used for rotation coppice, for maybe biochar, for example, to sequester carbon, so it can produce a crop. And then the other areas which are more open still we can use for sphagnum, blueberries, and so on. And then outside, these grassland areas, they can be partially re-wetted, and the farmer gets used to having a higher water table and how to address the issues. And then for the forestry, again, we have our trees growing very well underwater most of the year. So we need to convert from our spruce, which dies a quick death when you make it wet, and we need to replace our spruce with thorn redwood, alder, and these other species that are water tolerant. So that's that. I don't want to go on. This is just some of our celery trials. These are our forestry trials. Very pretty as well. Look, this is American sweet gum. Looks very nice wood, but it's also, the point is this is commercial timber. These are commercially selected timber species. These are our blueberries, okay? That's that. And this is our randomized crop design for the wet multi-species sward. Okay, just a couple of words quickly. We only have about 10,000 hectares. You guys have a lot more here of arable land. So the 30 tons of emissions, you can nearly double that with arable because it's all about oxygen into the peat. So when you deep plow the peat, you introduce a ton of oxygen and the emissions shoot up. And we work with England, and they've done trials with even the celery harvesting. When you pull up the celery, you have a peak of emissions because, again, you've put a load of oxygen into the peat and it degrades. So what they need to do here, and potentially what needs to be done here, is to move away from the more deep-rooted to the shallow-rooted crops and look at min and no-till techniques. So this is currently what they do a lot of in East Anglia: the rape, the barley, maize, wheat. Medium-rooted is peas, sugar beet. And then what they're doing is they're trialing these crops, which are growing very well. And we've grown these crops with a fully elevated water table in our trials. Okay, this is another possibility, of course, is, as you saw, the grass productivity does fall off regardless of what species mix we can have when we raise the water table right up. But we could have that with, wet adapted grasses, floating sweetgrass, reed canary grass as a fodder crop, So that maintains the productivity. This is our strawberry clover growing very well. This is our rhubarb. So we tried all of these things and these all do very well. But that's what we do. We always give the farmers options and we give them a range of choices and help them do what they want to do. I think so we've had a lot of success that way. Yeah, here's the cranberries, blueberries, floating sweetgrass, herbs and mint. These are two good crops. Incidentally, there's a list of paludiculture plants, as I said. One of them we discovered by accident because our farmer said, oh, we need some mint. I said, we need some mint. He says, oh, I'll get some from the local nursery. He got it, but it wasn't. It was oregano, but it grows brilliant. So oregano is another one on this list. So we've made some nice discoveries as part of this. This is our sphagnum trials. This is, again, forestry. Okay. And these are the ones. Again, these are the figures. This is from our agricultural research body, Chuggus. They claim you can make this much money per hectare if it's intensive. Sphagnum. This is the high-end use. So sphagnum moss used for orchid cultivation. This is supposed to be the figure you can get. And cattails, of course, you can use the stems for construction, which if you get maybe 20 tons of material per hectare is worth 3,000 to 4,000 a year. Up to 5,000 a year. And the fluff from the seeds is better than eiderdown as an insulating material for the fashion industry, which is an environmental disaster. So there's a crowd pond in the UK which take this and they pay 3,000 a ton. Okay, that's it. So essentially, went home, I'm doing it again. Oh, I'm definitely going the wrong way there, just to finish up, sorry. So that's basically our approach. With our farmers, we took what they gave us, we did what they wanted to do, they liked it, they did more. The farmers were looking, and unfortunately our project finished at the end of last year, but if we'd have had more money, we could have brought all the neighbours in as well. So it was a very successful approach. Just a proviso though, to make it impactful, we have to bring all of those groups of farmers together, because what we couldn't do is if a farmer had a field and there was a neighbour next door, we couldn't do anything with this. So we need to have areas working together. We need to have mechanisms and incentives. So we put in for another EIP, and we will be promoting land scale incentives to bring groups of farmers together, because that's the only way. Otherwise, we're just going to have a field here, a field there, and that's no good. We need to, because it's all about the whole hydrology. And then that's just our link tree. So we had a lot of publicity. So we're on national television, radio articles. So if you want to take that, there should be some good links on there. Just as a finishing, just to finish, those two farms I showed you, we are doing another project with Just Transition, and we'll be using that, and we'll be bringing peatland farmers from the area and showing them, look, these are the options, and we'll be doing surveys of their farms, and we'll be making recommendations. So we'll be advising them as to what is the best crops to grow on the different parts of their peatland habitats. Okay.